Sticking with the topic of innovation in relation to paragraph 79E, I'm just going to talk about a series of technologies that we've been using and evolving, innovating and developing since we built my house way back in 2008. And yeah, I'm just going to talk about the kind of the role of innovation in relation to this, because I think it's quite misunderstood. The term innovation doesn't mean pioneering, groundbreaking or invention, and I think sometimes the kind of weight afforded to what the role of innovation is in relation to these projects is quite misunderstood. Looking back right at the beginning of the policy back in 1997, the original version at PPG 7, paragraph 3.21, didn't even include any words relating to innovation or groundbreaking or anything like that. It was only first introduced when in 2004 when the PPS 7 paragraph 11 version came out, and then the term innovative nature of design and the term groundbreaking were introduced, but they weren't transferred into later versions of the policy, as I've talked about in previous videos. But anyway, through a series of PPS 7, paragraph 55 and paragraph 79 builds, we've been able to work on the development of innovation of a series of technologies to a point where we've got them working really well, and where certain sites are right for us using a combination of technologies, we're absolutely going to use them because they're brilliant. Anyway, when we built my house, the Crossway Passive House, back in 2008, we tested out some prototype panels which absorbed solar energy as heat and power. The idea being that we harness as much heat as possible onto a PV panel, take away the heat using a glycol fluid pipework system, much like any slinky system or solar thermal system. We extract that heat from the panels, cooling the panels down, with the intention that by cooling the panels down you improve the electronics and get more electricity per meter squared than you might otherwise with a PV panel. The problem at Crossway was, once we'd been monitoring the house, we were extracting that heat energy and putting it into phase change materials, and we tried out a few prototype phase change thermal stores, including microencapsulated paraffin wax phase change materials, resin, and paraffin wax bonded into resin, a company in Cambridge developed. But anyway, we tried lots of different things out, but we just couldn't find anywhere near the right amount of capacity to dump enough heat to be able to cool the panels enough to improve the performance of the PV. So our panels kind of got quite warm, didn't generate as much electricity, but they generated a lot of heat, and we generated some electricity, but not as much as we ought to have been. So on the next project we did, we used a later version of the evolution of the panel, and we needed somewhere bigger, somewhere with more mass to dump the heat from the panels. So we put a slinky system in the garden of the house, and using a water-to-water heat pump, during the summer we sent the fluid round the panels and round into and under the lawn in the garden to basically charge the ground up during the summer. So any heat that might have been extracted during the winter would be pushed back into the ground in the summer, and so improving the coefficient of performance of the heat pump during the following winter period, effectively recharging the ground back up again. And by having a large mass of clay in this instance, we were able to have plenty of capacity to keep cooling the panels even through a long hot summer. The system worked really well. The panels cooled very well indeed. The performance electronically was very good, thermally was very good. In the house we built after that, Echo Barn, paragraph 55 house in Kent, we took that a step further, and instead of putting that slinky system in the garden and still some of that heat would dissipate through the winter period and you'd lose it. We thought about moving that slinky system to be underneath the house. So we're using the house as the lid of a flask. And so what we did was had a fourth generation set of PVT panels, so a newer set of panels again, and took the heat from those panels and dumped it literally underneath the house in a series of small boreholes. And what we were able to do is take that massive bundle of energy during the summer months and store it underneath the house, heating the house up to a much higher temperature than we could the garden, and then store that energy underneath the house, using the house as a lid of a flask, insulated footings, and basically encapsulate that heat in lots of insulation and draw the energy out in the winter to provide the winter heat load. So it's a proper, viable, interseasonal heat store, and it makes the house phenomenally efficient and not requiring any gas or oil or wood burner or pellets or logs or anything like that. Literally just runs on sunshine. We took that technology a step further on our Headlands Paragraph 55 project in the Cotswolds AONB, and with that scheme we worked with similar fourth generation PVT panels. We also put a solar thermal system underneath the leaf-shaped roof. Leaves capture the sun and harness the sun's energy. That's exactly what we were doing at Headlands. We were harnessing the sun's energy, dumping it underneath the house, and using this energy we stored during the summertime to run the house in the winter time. So it's interseasonal heat storage, and it's a phenomenal piece of technology. But it's not necessarily right for all sites. Some sites don't have the right geology to make that happen. Chalk is not a very good substance to dump heat into, and we have a project, a Paragraph 55 house that we're currently building on the 70 metres away from the edge of the country, just atop the White Cliffs, and there we are looking to sink some much deeper boreholes and store the summer's thermal energy down deeper in the ground, because we can't dump it in the chalk in the same way we could the clay. But anyway, we've got this technology to work really, really well, and on certain sites with certain conditions, it's absolutely right to use it again, because it's through a series of PPS 7, Paragraph 55 and Paragraph 79 projects that we've been able to develop such a brilliant combination of technologies. And each time you could say that each system we're learning from the previous system, changing control systems, changing interconnectivity, making things smart home compatible, making things controllable from apps. All these things help make living with these technologies easier, and each one of those little steps is an innovation. Some steps are bigger than others, but the point is not all schemes need to throw new technology at them to be meeting the test, the first test of Paragraph 79E. There's a scheme we consent for at Appeal last year, and the house in a AONB, the first Paragraph 79 house that Wealdon District Council have allowed, was granted consent and at Appeal. But it was the way the house runs itself is on a log burning boiler with conventional PV on the roof. It's set in 40 acres. There's lots of biomass coming out of the site through annual management of the landscape, and we're just using logs to run our house. There's a very low heat load on the house because it's very efficient, but the amount of heat that's required is easily able to be served by wood we get from the site. So So it's a generate on site, use on site philosophy. And just standard PV on the roof. Nothing innovative about that. As it turns out, the log burning boiler we're using is a new piece of tech with some extra new innovations on. But there's nothing rocket science about using a log burning boiler and standard PV. But the inspector in the appeal decision actually pointed out that this is perfectly acceptable under the tests of paragraph 79. Useful case study. Hopefully some helpful context to the role of innovation. I'm going to do some other videos about some of the other tests in the policy, including more on innovation. There's lots to talk about on that one. But if you want to subscribe to our channel and see more, click over here. Or if you want to see the next video, click over here. I hope you're enjoying the videos and finding them helpful. Cheers. Bye.